One of the properties that we need to recover for discrete systems that we covered during the development of a comprehensive theory for continuous systems is the idea of physical realizability. Now, you'll recall that for continuous systems, we could determine physical realizability by observing the order. And so if we had g of s being made up out of a zero polynomial whole polynomial, if n was greater than m, we said that there was more derivatives happening in that in the top of the system than below, and because we couldn't build a pure derivative element, we couldn't build that system. In addition, we also had a criteria that if there was positive dead time, so in other words, if I had another g of s which featured a e to the plus ds, then we interpreted that as looking into the future, and we said that that couldn't work either. Let's look at this difference equation which I've written here, which is for a discrete system. Its transfer function would contain a polynomial in Z that contains the b's as coefficients, and a polynomial in Z for the numerator that contains the a's in the coefficients. And if we look at this system, we can see that we could write y of k on the left, and all of the other terms will either be an input at that same moment in time, so in other words, u at that same point in time, k, or previous values of the outputs. And if it is possible to do that, the system is physically realizable. Now, if this term falls away, the remaining terms in terms of y, we now see that y at the previous time step, so k minus 1 time step, is dependent on u at the next time step, which requires looking into the future. And this is not something that we can build. Now, that is the full version of the physical realizability check for discrete systems. So unlike for continuous systems where we had to check for calculating pure derivative and looking into the future, for discrete systems, because there's no way to express the idea of a pure derivative, we don't have to worry about that. We only have to worry about non-causal elements, which means that we only have to worry about this idea that we have a y of k, which is a function of things in the future, rather than this y of k, which is a function of things either at that same moment in time or in the past.